Now it's a good time to have a quick review. And yesterday and the day before yesterday, I have spent a lot of time just wandering to and enjoy the life with my friends and do something like the mountain and chatting and exchange our opinions about the life, the future, the present, and the something like mathematics a little, but mainly we also we were laughing, we were singing, we were um, just to go to mm, do a lot of things and it's a colorful day I think, but I think it's time for me to be silent, to be quiet, and to do something like a review or do some work, prepare for the study, and uh, the day after tomorrow, I think I will go to the competence, but I know nothing. Maybe I don't want to get there though, but depends on the God, I think. Anyway, so it's time for me to now. It's around the 4 p.m. So I think it's good time to have a quick review about the quantum gate and quantum circuits. And just 1 hour ago, I just read some book and record and just quickly, very briefly, very roughly to have a quick overview. I don't think this is the process of review. It's about also about learning. In my opinion, I think when I am just talking, I think I don't put all of my mind, all of my brain powers and all my intelligence to think, but I think I pay a lot of attention to how to express well. So it's cost a lot of time for me to do some reviews. So I think I should speed up and try my best rather than just uh, just wait and not focus well. So here we go. And this is about the quantum gate and quantum circuits. What I've learned is that there are just some basic thing like the basic vectors like zero, Kate, Bragg and Kate, then some exchange like X NOR gate, and H Harman gate, and the C NOT gate, and these are just some basic concepts, and then use them to represent the classical circuits. Also, we compare the traditional classical circuits with the quantum computing systems. So I do learn well about the mathematical thing like MPP and some PAC. What PAC? I forget. And something else. And there are a lot of potential like the logarithm and the dividends of the and some finding the prime and so on. So it's a lot of things. Okay, here we go. There's some basic thing like this. I think these slides are just from the basic thing, and also I need to do something and from the titles, and then to quickly to have a clear mind about things, that then just to verify what I have learned. So what is column vector is just a traditional concept that is it Bragg or Kate? What is bracket? Broad times Kate is Bragg is row and Kate is line, so it is also Kate column. And what I mean column? I'm saying that the column vectors are defined with an arrow. arrow with both bias arrow. Please notice that it also has a transport. Vice versa. Also, inner product means what bright times gate equals to a something like a number. What is inner relax? Row times column means the transpose time trans for k column for column characters we get and we can calculate the inner product to some. Also, matrix. What is the matrix? Matrix is a representation or transforming. It is okay. And vectors is just like okay. Let's a vector is just represent some information, dimension information, and it's just a representation like a rocket. If there's a K1, so I think this is a very traditional thing. It's about the adder. I think in general we denote a vector can as brand bracket from develop direct kit notation. Kit notation just some notations and what is it? It is just here we go. Let's check first postulate of quantum mechanics. Physical state of a system is represented by vector in Hilbert space. Hilbert space physical state represented by this physical state, and what is the phi RT related to the probability of finding particle at time t. Finding or at time t is the probability. Thus, this represents a state condition in a system. So, a condition they can represent the vectors in Hilbert and vectors Dirac notation. Dirac Kate phi prime means what? Then means right. That K is the transparent. If then what fucking thing? K notation means represents the inner product of the different and the past the different. So this what is the K notation? Every K notation have its bracket notation. It's similarly constant multiplier bracket transform means that it's a conjugate symmetry. Conjugate symmetry, that is to say, one way bracket times then we exchange then conjugate linear WRT, second one linearly, anti-linearly. Okay, it's a little bit tricky for me. Oh, this is some anti-linear. If we just for the kit we have linear system, but it's for the bribe we have anti-norm is positive definitely. Define it. Other properties like tranquil equality, score equality or circularity, and so on. This is just some linear algebra. And what is qubit? Qubit is a qubit. What is a qubit? It's just like a bit and represents some information like 0, 1, but it's a superposition for the qubit. Quantum bit. Quantum bit. But it has a superposition that is to say a qubit is a qubit is a structure with 0, 1, 2, so that's my answer. Why we use a qubit is similar to a classical bit in that it can take on 0 or 1 as states. A qubit is similar to classical bit can take but it differs from that can constitute continuous range and the 100 qubit 1 to 100 and conventional base versus photonic qubits. Photon is a source and reflecting a transparent 0 and 1. What does it mean? It means that it's random, the property of random. A qubit, the definition is that two-level quantum mechanical system, as we will see in the current chapter on building block, we can represent the qubit two-dimensional complex Hilbert space C22. State of the fucking thing. Tensored together, which represents n qubits, is initialized to state 0, and tensored together. We can further signify a number of qubits as part of a register in the following. A qubit is vector space. A qubit is represented by a vector space, more specifically, a Hilbert space. Okay, I should focus on what I am doing now. We can further signify which represent the m qubit in a 0 and tensor. What is the meaning of tensor? I don't know. And a qubit vector we sometimes call the Hilbert space representing the qubit. Qubit is the state space. The state in the state space is vector in space with L2 norm 1. So a state is a Bloch sphere with a collection of n qubits and the quantum ratio noted as n times. It turns out the tensor product of the I know what is the tensor product. It means it's a similarity to do the same thing. It's just like 1 0 times 1 0 is 1 0 0 0 and 1 0 1 0 1 0 1 0. Oh, it turns out the tensor product here is another here, but the tensor is also tensor, only have a greater dimension. Here, but and key notation and quantum using quorum with complex combination. How to learn about key notation? It's just like a vector, but we can generalize its meaning. We can use complex even both alpha and beta. We can represent based on the basis that is 0 case and 1 case, so that we can use. But to be pay attention to the complex number. What is bracket? In the departure from regular algebra, there is a well-defined dual vector for each quantum state called a bra. Well-defined dual vector for each quantum state called a bra, which we can obtain by taking the complex conjugate and transport of the. What is the meaning of bracket? In the departure from regular linear algebra, there is a well-defined dual vector. Well-defined dual vector for each quantum dual vector called bra, which we can obtain by taking the complex conjugate and the transport of the etc. This is the important for dual vectors equal to brass. That is to say, we transport and then I think this is the unitary. I don't know what is U in Chinese. U. I don't know what is inner products equals to bracket. Inner bracket times gate and either some measurement. What is the meaning of measure? One way measurement it will collect and we have only one result. So even if we can parallelize computing a lot 2 to 100 to even 500, it's more than the parser in the universe. But after what the once measurement, we only have one result and we lost a lot of information about other things, because of it's not it's we cannot inverse this process. It's not one-to-one. I don't know well about this process, but the main idea is that we lost information. We lost information, I think. A central feature of quantum is that when we perform, okay, this is just what we say. I don't know what is the in the verb from there's well defined what is the dual vectors equal to breadth. Oh, I think this is just some name. Normalize. What is meaning of normalize? Normalize means this such a manner on a qubit state must result in zero, and what these weird magnitudes must sum to one, since they are probabilities. Because this is just some regulations for the vectors in the qubit states. We can also express qubit states in different bases. Okay, this is just some basic of this, that this some regulation, basic regulation. It's very easy for us to represent other things because they are just, I think it's a little beautiful because of the symmetry and norm, I think. And okay, I think when we are teaching, we do something, we should be energetic and excited to output. This is the question: if any basis is just as good as others, is there a basis that we should use as default? Okay, that's just a notation. Representing superposition, the two states allows for constructive interface and destructive interface. The amplitude state interfere destructive. What is the meaning of the amplitude? It means the possibility for the result. I mean that when we mentioned how the possibility, how it's possible for us to measure it out. So on the other hand, the amplitude of the state in various conjunctions, they have the same sign relative phase, so they don't sum to zero. Okay. This is something that some point that we will test. What is the amplitude? Refers to both magnitude and the amplitude means the magnitude and the relative phase associated with some value from a qubit superposition. The magnitude of the amplitude associated with each value the magnitude of the amplitude of both magnitude and relative phase is related to the radius of the field in a shown. What is the meaning of the phase? The phase between is indicated by notation circle relative to 0x. The inverse clock, counter clock, yeah. Relative phase is the relative phase of a single qubit. The relative phase has no effect on the magnitude. However, relative can provide an astonishing computational advice we can provide because it's continuous and a lot of possibility. The relative phase are the same. The two states are equivalent because the relative phase are same. Multi-qubit states, the uncommon we use a different kind of matrix, product called the tensor product or Kronecker product. To take the tensor product of two matrices A and B, we write out a block matrix where each block is equal to B times the appropriate element of A. To take the tensor product of two matrices A and B, we write out a what is the meaning of the superposition? Not super multi qubit states. We use the the tensor product. To accomplish, we use a different matrix called tensor product or Kronecker product. To take the tensor product to them, we write out a product where each block is equal to B times the appropriate element of the A. The upper left block is B times the upper left element of A, and so on. And so on, A times B. Okay. Oh, I should focus on the present. Okay, I think we should do more than the recording the classes. I think we should output my ideas, opinions about the life and what I have seen, what I've learned, what I am doing. These things. Oh, this is the planning. So this is just the insight, not insight, just the something occurs in my mind. So don't pay attention to it. Pay attention to the present. Come down with the. Okay, I think this is just a arithmetic operational. Okay, what is the I is the last thing. Oh, I don't think I is that thing because the I, what is zero, what is one? Oh, I forget what is identity. Let's continue. Oh, one zero. Okay, this is just a representation we should pay attention to. Oh, these are just something that we just neglect the tensor product. Okay, this is, oh, we should and we could to represent the same product state, and we call the factor of the product into the individual to n. Harmonic oscillators. The device is to store and manipulate quantum states. Such a default basis. One such device is the harmonic oscillators. Hamiltonian, which is the matrix says. Assign the energy to each eigenstate. States are orthogonal. What is the meaning of the store and manipulate qubit states provide such a default basis? The Hamiltonian states are orthogonal from a computational basis. Harmonic oscillators. I don't know what is the Hamilton. Okay, continue to the finite dimension F. Finite dimensional systems. What is the dimensional system? Finite. What is the harmonic oscillators? This infinite dimension. Infinite dimension. Is a qubit timeline. Such devices include the pin qubit timeline estimates millions of physical qubits, decoherence errors. Dates are speculate. Dates are speculate. Decoherence errors of timeline estimation and then something. Okay, it's time for me to do this thing, I think. I think we should compare the state of classical qubit. I don't know what is the manufacturing thing. The block still. I'll pay attention to. I think a lot of time for me to spend to just spend on the other side, like the Alibaba and something like the yours mathematical competence. Okay, to get information from bits. Information acquired state. After information acquired, go ask Alice, can state be earned from bits reversible operations on state subsets of n bits? The Bloch sphere. The Bloch to show how the QB is just a visible ball, or I think the Helan, yeah, from yeah. So how qubit states can be mapped to the surface of a sphere. Let's start by expressing the coefficients of alpha. Okay, as you can pay attention to the present. Blockchain to show how the qubit stands mapped to the surface. Let's start by expressing the qubit alpha beta. Polar coordinates like what? Why we don't use the alpha? Because k multiplied by a phase That's the same, not different in the result in a simpler. Yes, simpler expression which results in a simpler expression for the state, but it's not yet as simple as it can be. But it's not yet as simple as it can be. What is simple? Oh, it's not the as simple as it can be. So global base doesn't matter. Global base bracket relative base is the phase difference relative complex exponents for the why? Be patient. Stay hungry. Stay foolish. I don't know what is the product of class. This is the aim of the design. What does this mean? Okay, I think I think I think I think should I think from a direction of designing, and what should we design to design the whole system? I think this is the correct direction to think. Something a little bit tricky. Operators. What is a hand with outer? Oh, there's different kinds of things like inner means this, the, and outer means that, and the tensor means that. Okay, quantum register is a tensor product. Quantum register is a tensor product. Quantum y align with no operator on implies that it remains the previous state. Okay, what we have lost is just about the Bloch sphere. Next week, okay, tomorrow. Oh, I don't know when should I to explain it. We'll just neglect it. Thank you very much. Goodbye.